Hello and welcome to the course on C Programming Learn to Code series. This is the 12th lecture of Unit 2, and in this lecture we will continue our discussion on number representation in computer. In the last lecture we talked about signed magnitude representation, and in this lecture we will talk about ones complement representation. So let's begin. So the representation in ones complement representation is quite similar to the signed magnitude representation. The overall architecture is same. Suppose the given word is 8-bit word, then the first bit is always used for representing the sign bit and the remaining bits are used to represent the magnitude. So magnitude means the given number has to be represented in this particular place. If the number is given as positive number, then the sign bit must be 0, and if the number is given as negative number, then the sign bit must be 1. Now let us understand how the given number is represented in this particular place. Okay, so let us take an example. So for the first example that we are going to take is plus 5 in 4-bit word. I would like to convey one thing over here, that in ones complement representation compared to sign magnitude representation, the positive number representations are same. So it is quite similar to the signed magnitude representation. So suppose a 4-bit word is given where the first bit represents the sign bit and the remaining bit represents the magnitude. So to represent positive 5, what we are going to do is we will first convert the given number into its binary equivalent. So 5's binary equivalent will be 101. So I will directly write 101 in this particular place, and as it is a positive number, so the sign bit will be 0. Now if the same number is given and I want to represent it in 5-bit word where the first bit represents the sign bit and the remaining bit represents the magnitude, what I will do is I will represent this binary number, binary value of 5 over here 101, and the sign bit obviously will be 0 because it is positive number, and the remaining box will be filled with 0. Okay, so interesting thing is, if when you watch the conversion, it is quite similar to your signed magnitude representation. But when we are talking about negative number, then the representations are quite different. So let's see how the things are different. Now I want to store minus 5 in a 4-bit word. So what will happen? Suppose the 4-bit word is given, the first bit represents the sign bit and the remaining bit represents the magnitude. So to store minus 5, what I will do is I will first convert plus 5 into its binary equivalent, but it should be represented in 4-bit. So binary equivalent of 5 is 101. So to make it 4-bit, I will put 10, means a single 0 on the left side of that binary equivalent. Okay, so after making this 4-bit, what I will do is I will apply the ones complement. So what do you mean by ones complement? Ones complement means altering the bits from 0 to 1 and 1 to 0. So that is called the complement. That means we have to complement each bit. So this 0 becomes 1, and this 1 becomes 0, this 0 becomes 1, and this 1 becomes 0. So that means this is the ones complement representation of this particular value. So I will directly write over here 1 0 1 0. So this is the representation of minus 5. So you can see here the sign bit is already 1, which represents this is a negative number. Okay, so now if I want to represent the plus 5 in minus 5 in 5-bit word where the first bit represents sign bit and the remaining bit represents magnitude, how will I will do that? I will do the same procedure. So I have to convert the positive 5 into its binary equivalent, that will be 101, and as I am going to represent this value in this 5-bit word, so I will make it 5-bit. So how to make it 5-bit? I will put 2 zeros in the left side to make it 5-bit. Now the next step is I have to find out its ones complement. So what is the ones complement of this value? This will be 0 becomes 1, this 0 becomes 1, this 1 becomes 0, this 0 becomes 1, and this 1 becomes 0. So now this is the ones complement representation of 5. So I will directly write 1 1 0 1 0. So now you can see the sign bit is already 1, which means it is a negative number, and this represents the negative 5. Okay, this is how the ones complement work. Now let us see for a 4-bit word the entire process, means how much value get how it is represented. So in one's complement representation, if you see for 0 to 7 the representations are same. So 0, 1, 2, 3, 4, 5, 6, 7. It is quite similar to your representation that is given. Let me change it to this highlighter. Okay, so it is quite similar to that value, sign magnitude representation. Now if you want to represent -7, so the things are getting different. So here you can see the -7 is actually represented with 1,000. So how it is, let us understand it properly, then I can explain you other values. So -7 means, so if I want to represent -7, what I will do is I have to convert +7 to its binary equivalent. So the binary equivalent of +7 is 111, and I want to represent it in 4-bit word. So to make it 4-bit, I have to put 0 over here. So now I have to convert it into ones complement. So the ones complement will be 0 becomes 1, 1 becomes 0, this 1 becomes 0, this 1 becomes 0. So the value is -7. Similarly, to represent -6, what is the value? So if I want to represent -6, then first of all I have to convert 6 into its binary equivalent, which is 110. This is the value of 6. Now if to make it 4-bit, I have to put 0 over here. Now I have to convert its ones complement. So the ones complement will be 1001. So you can see this is 1001. Similarly for 5, you can find out 5, 4, 3, 2, 1. Okay, so let me calculate for 1 also. So if it is 1, so 1 means the binary equivalent is 1. Now to make it 4-bit, what I'll do, I'll put 3 zeros over here. So after putting the 3 zeros, I have to convert it into ones complement. So after putting the ones complement, what I'll get? 1110. So this is 1110. Now it is peculiar thing is over here is, so whenever I want to put 0, I want to store -0, there is also a representation. So that means I have to convert 0 to its binary equivalent, that will be 0. To make it 4-bit, I have to put 0, 0, 3 zeros to make it 4-bit. Now ones complement will be 1, 1, 1 and 1. So that's why the negative number, for -0 also there will be a representation, which is obviously a disadvantage because +0 and -0 are both same. Okay, so let us summarize the whole discussion. So as I have already told you that from 4-bit, 3 bits is used to store the magnitude, as we have already discussed. So that means with 3-bit we can represent 2 to the power 3, that is 8 different numbers. So here you can see we can represent in 3-bit, we can represent 8 different numbers, 1, 2, 3, 4, 5, 6, 7, 8, right? So if it is 8, for positive it is 8, and for negative another 8. So hence in our example, the range of the number that can be represented with 4-bit will be -7 to +7. Okay, we have already discussed, and the general formula will be if n bit word is given. For an example, suppose given that 5-bit word is given. So if 5-bit word is given, how many numbers can be represented with this? Using your ones complement representation, that will be -2 to the power 5 minus 1 minus 1 to 2 to the power 5 minus 1 minus 1. So what it will be? It will be, this is not minus, here it is minus. Okay, so 2 to the power 4 means 16 minus 1 is 15. So that will be -15 to, this will be 2 to the power 4, this is 15, so +15. So the range will be -15 to +15 if 5-bit word will be given. Okay, similarly you can find for any number of bits that is given for you to represent the numbers. So as I have already discussed, that there will be 2 representation for 0, which is the disadvantage of this ones complement representation. So if we compare ones complement with your sign magnitude representation, both are representing the number, the positive number in both the cases are similar. For negative number, both cases are different to each other. Now the disadvantage has not been eradicated by ones complement. The disadvantage is still remain over there. So who will solve this ones complements disadvantage as well as sign magnitudes disadvantage? This will be solved by your 2's complement representation, which I am going to discuss in the next class. So that's all for the today's class. Thanks for listening. Now you have to solve this homework, that is your using ones complement representation, how to represent minus 75 in 16-bit word. So that you can try and send your answer in the comment window. That's all for today's class. Thanks for listening. Bye bye.